Hello and welcome to the second demonstration of Sovereign Boot Provisioning Wizard. This presentation summarizes the progress of the development in the second phase of the project, which involved mainly the signature and certificate parsing, as well as adding the certificates and images to the trusted or forbidden signatures database. If you haven't watched the first demonstration video, I highly encourage you to do so because many concepts and the goal of the application has been described in the first video. Now I will just simply continue with explanation what has been added and how it overall looks like. So, as usual, we are prompted to choose between the Sovereign Boot and the standard Secure Boot. So right now this option is activated. So you can either choose the Sovereign Boot, which will wipe out your current Secure Boot keys and start the provisioning process, or simply you can choose the standard Secure Boot with Microsoft certificates, which will of course enroll the firmware's default certificates and enable Secure Boot with those certificates enabled. So to show you how it works, we can just select the standard Secure Boot Microsoft certificates, and the window says that the default keys have been restored, and we may reset the system to simply use the default ones. And I will show you what are the defaults in the firmware, just to prove that it works. So we can enter the custom mode and query the keys. So here we have a sample Dasharo platform key enrolled. The key contains the Microsoft keys, and the trusted signature database contains the Microsoft and Windows certificate authority certificates. So now if we would like to provision the system again, we must simply enable the Sovereign Boot back, because if we choose the default Microsoft Standard Secure Boot, then Sovereign Boot is automatically disabled. So once we enable the Sovereign Boot, we have the option to launch the Sovereign Boot Wizard. However, we have made some changes to the system configuration, so we have to reset it first before we can actually start the provisioning process. And now, if the system is unprovisioned, we are again welcomed by the Sovereign Boot Wizard, and then we can just start the regular provisioning. So this time I will just select the Sovereign Boot, so that I will show you how the current look of the application is. So I have mounted some sample UEFI system partitions to the QEMU machine, which has some sample grab and shim bootloaders, just some sample files that will help me show you how the wizard works. And for example, right now we have the standard description of the boot option, which was present in the previous phases, but right now the view is extended with the certificate fingerprint, which is the SHA-256 hash of the certificate. To be precise, it is the hash of the to be signed part of the certificate, so everything except the certificate's signature. We can also inspect the details about this certificate. To do so, we just have to enter this show key certificate details submenu, which will present us with some more detailed and human labeled view of the certificate we are currently trying to decide on. So it shows quite some basic information, and the layout is mainly inspired by how OpenSSL displays those certificates. So we can have a hexadecimal number of the serial number, you have a common name of the issuer, the common name of the subject of the certificate, and its validity. Of course, most important is the key modules, because the validity and names and serial number may be freely set, while key modules is typically generated randomly and is not so easy to fake. So here we can just investigate how this key modules looks like. And of course it is slightly different from the hash you would see there, because the hash contains the key modules itself too. And of course we also have the information about key exponent, but it is usually the very same number all the time. So it is a hex number of 10,001. Now that we know some information about the certificate, we can just make a decision. So the first, let's say, button will simply add the bootloader to the forbidden signature database. In Secure Boot nomenclature, it is called DBX. We can also trust a given key or image and simply boot it directly. This operation will cause the certificate to be enrolled to the allowed signature or trusted signature database, which in Secure Boot nomenclature is called DB. And we can also trust this key and simply proceed to the next one. If we do not want to give any trust to this key at this moment, we can also skip this key or image and proceed to the next key bootloader. This option is new and has been added for one major particular reason. Because there may be multiple certificates and signatures in the file, simply marking it as untrusted would cause the whole image to be untrusted as well. So we will not be able to process any more keys because they will be already untrusted, no matter what we do. So if we want to, for example, proceed to the next key, simply do not give any decisions, it will still mean that this signature or certificate will not be allowed to not pass the verification and allowed to execute the image. So it is fine if we also skip. So this time I will try to skip and proceed to the next certificate. You can also inspect what is the details about this. And right now we have Microsoft UEFI driver publisher certificate, which is issued by the Microsoft Corporation UEFI CA from 2012. Right now we show the Microsoft certificates as an other certificate because the addiction of Microsoft certificates is not yet implemented, but will be added, of course, in the subsequent phases of the project. So let's say I don't want to give any decision right now about this image, but I would like to, for example, trust this image. I have some Red Hat shim, which is also signed by the Microsoft Corporation UEFI CA, or rather, this CA is present in the chain because CA directly cannot sign any images, but I also show the CA certificates in case that these are also present in the chain. So let's say I want to trust this key or image and proceed to the next bootloader. So we have a confirmation pop-up just to not make any mistake. So if we mistakenly press enter when we have not highlighted the correct entry, we have a second confirmation needed to actually confirm the operation. So let's say I want to trust this image. Oh, I have a warning window showed up which says that the signature verification failed with this certificate. What happened? Actually, this particular image has been patched by me just to show you this particular functionality. So I just modified a couple of bits inside the image so that the hash of the image would not match the hash inside the signature. That is why the signature failed, and the wizard warned us that we cannot add this certificate as untrusted. So all I can do now is simply press enter and abort the process, and nothing else is allowed at this point. So the wizard in this situation will go back to the decision process and do not move to the next bootloader or key. So what can we do in such case? We may either do not trust this key or CA. It will result in not trusting any other bootloader that is signed by a certificate that was issued by the CA. So we can either skip it or do not trust it. For the purpose of showing you all possibilities, I will right now skip this one. And the wizard simply moved to the next detected certificate inside the image. So we can now see that the wizard moved to the next certificate in the chain. Previously we had the Microsoft Corporation UEFI CA certificate, and right now we have the Microsoft Windows UEFI Driver Publisher certificate, which was issued by the aforementioned CA. So if we would trust or do not trust if we do not trust the CA, the wizard would simply automatically skip this certificate because it will be automatically untrusted as well because of the relation to the UEFI CA. Alright, let's skip this one as well. And now I have another image. This time it is some grab image from Fedora. So let's show this certificate, and you can see we have some different certificate right now, and it is called the Fedora Secure Boot Signer, and it was issued by the Fedora Secure Boot CA, which unfortunately is not present inside the image, so we simply cannot use the CA to enroll to the forbidden or trusted signature database. However, notice the validity dates. This certificate is valid only between 2012 and 2022. So if I try to trust the certificate, the wizard will simply deny the operation because of the certificate validity. Right now we have 2025, so obviously it is past an expiration date. So even if we attempted to trust this certificate, any verification involved this certificate would simply not pass. That is why we cannot add it as untrusted. So what can we do? Let's try to untrust this. Okay. And we move to the next valid bootloader that has a certificate that we do not yet give any decisions. So let's show the certificate again. This time it's some Debian shim, so we can expect a Microsoft certificate. And as expected, this is another shim signed by some Microsoft certificate, which originates from the Microsoft Corporation UEFI CA. This time I will try to trust this image and hopefully everything goes well. And yes, this time the certificate has been added as trusted, so the wizard moved to this next certificate. As we already trusted the CA, we may simply skip trusting this Microsoft UEFI driver publisher, which was issued by the CA. If we decide to not trust it, automatically the whole Debian shim will not be trusted, despite we have added the CA to trust it. So we'll skip. And as a last functionality I would like to show you is the parsing of unsigned images. So if the wizard happens to find out that the image does not have any signature, it will present us with the executable image hash instead. So this is the hash that the image will be usually checked against if it is added to trusted database or forbidden signature database. So if we do not want to trust any unsigned images, we may simply proceed to do not trust, and I will select this option because I would like to show you later the results of our provisioning process. Okay, and now another double confirmation, and the wizard already detected that we have iterated over all our boot options, and so it informs us that no more bootloaders has been found. And to finalize the whole provisioning process, the wizard will have to create an ephemeral platform key and enable secure boot. What is this ephemeral key even about? As you may know or may not know, UEFI Secure Boot cannot function properly if the platform key is not enrolled. So what we do is generate RSA 2048 key, take its public part and enroll as a platform key to the secure boot variable. And then after that is done, we simply discard the private part so that this key will never be used to modify the configuration of Secure Boot, but it will let us to enable the Secure Boot and enforce the verification of the images. So when I press the Enter button, it will simply proceed with generating this key and finalizing the provisioning process. And yes, it informs us that the provisioning was successful, so we already have the Secure Boot enabled, PK enrolled, and all our trusted and forbidden keys and hashes configured. So right now, after we press the Enter button, the wizard will simply proceed with booting the first bootloader that we have trusted. Of course, this behavior may be changed to later select any trusted bootloader from some list or some sorts of, but right now we have a very simplistic approach to boot the first trusted bootloader. So after pressing Enter, I should be welcomed by some grab prompt, right? Because if we have trusted a shim, the shim automatically changes the execution to the grab bootloader it is usually paired with. So right now we have a grab shell, so it means that the verification passed and the image was booted. So now if I type the exit command, the grab will exit, and after the provisioning will be landed inside the setup. So to inspect what changes we have made with the Sovereign Boot Provision Wizard, we can enter the Secure Boot configuration menu. Last time I mentioned what are these options for Sovereign Boot for. So right now, once we have enabled and implemented the provisioning process, this variable here that shows the provisioning state is already showing us what is the current state and that the provisioning actually works. So now to inspect the forbidden and trusted signature databases, we can enter the Secure Boot custom mode, then enter Advanced Secure Boot Keys Management, and then we can simply go to DB options, choose the delete signature, and as we can see, we have trusted the Microsoft Corporation UEFI CA certificate, so it is present in the trusted signature database. Now proceeding to the forbidden signature database, so DBX, we should see the signatures that we do not trust. So a little bit about this one. The first signature list is actually the default forbidden signature list that is provided by UEFI Forum. This is an exception here because the Sovereign Boot Wizard, when decided to use the Sovereign Boot, it wipes out every secure boot variable, well, except the forbidden signature database. Because the UEFI Forum provides already the forbidden signature database for non-vulnerable images, it is not wise to actually wipe it out. So we keep the default one and simply append our own untrusted keys to the next signature list. So the default signature list currently has over 400 SHA-256 hashes with forbidden and vulnerable images, so we will not be inspecting those. But instead we will simply proceed with inspecting the certificates and image hashes that we enrolled ourselves. But how it can be distinguished between what is default and what not? So the signature lists have also their own owner GUIDs. So as you can see, each signature data has its owner GUID, and for the default ones, the owner GUID will be as follows. It starts with 77FA, etc., etc. However, if we inspect the entries added by the Sovereign Boot Wizard, we will see that the owner GUID will be different. For Sovereign Boot Wizard, the owner GUID will be B5703, etc., etc. Also, the help window on the right will show us what given signature data entry contains. As you can see, it contains the SHA-256 of a certificate that we decided to not trust. Also, the signature data that contains a certificate hash must also provide some revocation time. In case of Sovereign Boot Wizard, we always set the revocation time to 0, which will mean that given certificate hash is always untrusted no matter the time. One may also specify some revocation time here when the given certificate should be considered untrusted. However, for simplicity, we just set it to be untrusted forever. And of course, we have also a second entry which was added by the Sovereign Boot Wizard. And if you remember correctly, we decided to not trust the Shower Toolsuit grab image, which was not signed. And if the image is not signed, we can only enroll its image hash to the forbidden signature database. And as you can see, it is the SHA-256 of this image here that we also saw on the screen in the provisioning wizard. And that summarizes the current capabilities of the Sovereign Boot Wizard. Hope you liked it. And of course, I'm also open for feedbacks because there are many concepts that may be changed. For example, how to enroll the certificates, whether to enroll only the CAs if they are present in the images, or whether to do more checks about the certificates. For example, to enroll a certificate with invalid date, but let it later decide for the user to boot the images even with the invalid certificate or not, etc., etc. And thank you for watching and waiting for your feedback. Thank you.